Bit of a marathon today, huh? But we're not done yet. I hope you've had fun. I have, definitely. It's been a good video. I've been full of glee at points even. So let's reflect on a few different ways of thinking about testing. And I'll start by talking about autograders, which we talked about at the very beginning. So the idea with autograders is there's some kind of magic oracle that tells you that your code works or not. And it turns out, by the way, that the autograder we use for this course is based on JUnit, plus a little bit of extra stuff in a library called JH61B that I named after myself. So autograders are not necessarily a problem, right? I mean, there are great things about them. One, it avoids you having to spend all your time doing boring stuff, writing tests that really don't teach you anything, because your time's valuable. The most precious resource in a teaching setting is student time, and so we try to save you time where possible and only make you do work that we feel is actually instructive for you. Another thing, of course, is it helps us determine your grade, which is a thing we do in modern society for some reason, is give you letter grades, and this helps us do that. And it also gamifies correctness, because there's these delicious points you can try and get, and by having an autograder that doles them out very stingily, it helps make it into kind of a game. Now, that's not always a great thing. I've seen students spend all night trying to chase their last point, even though it doesn't actually affect their lives because the game's so fun. So, hey, I don't know. It's good and bad. But there are reasons that autograders are not such a great thing to rely on in a course. One is they don't exist in the real world, so you can form these bad habits. Another, of course, is that the errors that the autograder gives you can be hard to understand. Maybe what we anticipated you running into is not what actually happened, and so the errors are useless. Third, it's very slow. If you have to submit your code and wait 5 minutes, then make changes, that can be not so great. And of course, if the grader somehow breaks or misbehaves, you're kind of out of luck. You just have to wait until someone fixes it, maybe. Now, what the autograder can lead you to, and I talked about bad habits, I'm going to talk about the absolute worst case scenario, which I do see happening sometimes, which is called autograder-driven development. So in this approach, this is the worst way that you can possibly program in this course. And maybe you have some of these habits, and I just want to raise this point now in case you do, so you can try and break them. It's to, a student who follows this workflow reads and mostly understands what they're trying to do. They then write the entire program, maybe 200 lines of code, who knows. They compile the code, and of course there's a bunch of compilation errors along the way. Now if you're using an IntelliJ, like in development environment, you actually fix the compilation errors as you go, which is great. But I've seen students who, in Project Zero, for example, when they're working from their command line, just write tons of code and then fix the compile errors later. And then once you've got all the compilation errors fixed, you send it to the autograder, and then you get back tons of errors because you haven't even run your code locally. And so then what you do is you repeat the following steps randomly. You run the autograder, you add print statements that you think will help you, and you end up with something like this, where the autograder is spitting out output that's some arrays. It says got here, got to this spot, and some variables. And then finally there's the test failure message at the bottom, and you're kind of mining all of this text for like clues to what went wrong. And then you try and make some changes to your code to fix the bug, and repeat these over and over until eventually you converge to correctness. Okay. So this can get you something, and you can learn in this way, but it's just brutally slow, and I think you end up wasting tons and tons of time doing something like this because you're trying to get those extra few points. So I'm going to say this workflow is incredibly slow. It's a bad habit. It's unsafe in the sense that it's unsafe to like your learning process. I mean, you're in some sense just guess and checking. I mean, maybe it's an enlightened guess and checking, but it's messy. Okay. Now, I do want to note that I don't actually have a problem with print statements for debugging. I think they could be really, really useful. They're very easy to use, which is great, but I think they're a weak tool. But I use them all the time. In fact, this code up here is something that I literally did when I was trying to debug an implementation of Quicksort that I'd written in Python, I think. And I had the bad idea of trying to add some print statements because I thought I was really close. In fact, I was pretty far when I was trying to fix it. I don't even remember what the story was. So I do this sometimes locally. I haven't done it with an autograder in a long time, but hopefully it's something you don't do. Okay? So I'm using this as a straw man to say this is the worst case. And now let me tell you about what this new world unlocks for you, what unit tests do for you. So with unit tests, the idea is rather than relying on some monolithic magical autograder, you write tests for every piece of your program, or at least a lot of them. And what we'll refer to each of these pieces is as a unit. And so JUnit makes this easy. I mean, you saw that code before. It's so simple. Look at this. This is barely anything in my test sort method. Now, there's some great things about this. One, it allows you to have confidence in your basic pieces, swap and find smallest. You feel really good about the fact that they work. There's like these dependable minions that you can call on when you need them to do something for you. It also helps because it decreases the time it takes to debug. I can restrict my attention to only one method at a time and avoid any kind of print statements that involve jumping from place to place to place. And third, it can help clarify the task that I'm trying to do. If I'm trying to sort, I have to know what sorting is before I can write test sort. If I got to write find smallest, when I write my test for find smallest, it helps clarify what I'm trying to do. Now, the reasons we might not want to do this is each of these pieces takes time. And in an instructional environment where time is incredibly precious and 61B is competing among all the other life issues you have, other courses you may have, I don't know, maybe you have babies, maybe you have a job, this takes time away from the rest of your life, sleeping, whatever it may be. So we don't want you to do that all the time, but we do want you to be familiar with it. Another issue is it could build false confidence, right? Like you write a test swap and then there's actually a bug in swap, but you have another bug in test swap that keeps you from seeing that bug. So you can end up with false confidence where you believe that your minion is doing your bidding, but actually it's not. And then another thing is that it's hard to test units that rely on other units. So for example, in project 1, how do you test the add first method alone, right? You need some way to get stuff back, or maybe there's some complex interaction between add first and remove first that unveils a bug. So sometimes it's hard to actually test a specific unit. Now, once you have unit testing in your brain, just to give you a sense of an opposite philosophy for autograder-driven development, let's talk about something known as test-driven development. So this is a real-world idea that was very, very popular. It's kind of lost favor, but it's still out there, right? And I don't want to get into it, but the steps according to this process of capital T test-driven development are: first, you identify something you want to do, some new feature. I want my class to be able to sort things, or I want to be able to process Bitcoin transactions, whatever it may be. And then what I'm going to do is write a test for that feature first, before I write the code. It's test-driven. That happens first. I'll then run the test, and it should fail, and that's red. Like my IDE or whatever I'm using to run my test code, it should say, no, your code's not working, and that's great because that gives you a task to solve, and it tells you that the test, at least, is not passing when it shouldn't be. You then write code that passes that test, and then you go to the green mode, which in Eclipse might look something like this. And in IntelliJ, we saw that green bar. It's very exciting. We get the satisfaction of knowing my code works. And then I can actually say, you know what? Now that I have code that works, I can actually make it better. So the code is certifiably good. And so any change I make now, I have basically a test that acts as a reference to say that my code still works. So if I want to make my code faster or make it more beautiful, I can do that and see that it still works. And if maybe in the process of speeding it up I make a bug, I know about it immediately without breaking the whole system that I'm building. Now this is not required in 61B. I'm just mentioning it. You might hate this idea. Maybe you don't like the idea of writing tests first at all. But I'm going to say that testing is a supremely good idea. And there's an interesting perspective on why people who use the official test-driven development process kind of moved away from it. And I found this to be one of the best articles about that process. So test-driven development, it's an extreme departure from the naive workflow where we run the autograder over and over, or in this case, run it locally. Slightly different picture than before. Oops, busted, but I'm not going to fix it. Oh, geez. What am I doing? All right, let's go forward. I'm wasting your time. So what's best for you is probably somewhere in between this approach where you just run the autograder over and over and hope it works, and test-driven development. Something between these two is something good for you. Okay. Now, I want to mention that unit testing, as we alluded to earlier, does not solve all our problems. We want our tests in this notion of integration testing to cover many units at once. So ArrayDeck, for example, we have all these units that interact in complex ways. And so JUnit, even though it says unit and it's focused on unit testing, you can actually use JUnit for this process, even though it's not the focus, the intention of JUnit. And so what's good about this is it allows you to run tests that ensure that all of your pieces interact properly, or that your entire system works as expected. But the bad thing about integration testing is that it can be really tedious to do manually. So suppose the system that I'm testing is an entire game, like what you might build in Project 2. Doing it manually could be a huge pain in the butt. But on the other hand, it can be really challenging to automate something that involves complex interactions with a user. And another issue is that testing at this very high level of abstraction, where you're looking at all the pieces together, it can miss subtle or rare errors that only occur only occasionally, as opposed to unit testing, where I can really put all of my energy into making sure that swap is working. Okay, so all of these three tools are useful to you in 61B. That is using an autograder, using unit tests, and then doing some kind of big integration testing for our entire system. And in fact, our autograder tests are a combination of unit tests and integration tests. Okay. So some very last thoughts before we end our day. JUnit makes writing tests just super easy. And I'm going to suggest strongly that you write tests, but you don't want to write too many. I think test swap, for example, in this lecture, probably a little silly because swap is such a basic operation. So I'd say only when they're really useful. Now, I'm going to say that often I personally like actually writing tests first. It helps me clarify what I want to do, and it gives me ground to stand on. So if that feels good to you, if that feels appropriate, great. But be aware that I love doing it all the time, especially when I'm, say, writing the autograder for this class. I write tons of tests for the autograder code. Now, when it comes to this course specifically, Lab 3, Project 1B, and Project 2 are the places where testing is going to be most important. There'll be lots of assignments after that, but anywhere in the course, write tests when you feel like it might be useful for you. But for most of the course, we're not going to require you to write tests because I want to save you some time, but I do want you to be exposed to these ideas because they're incredibly important. I'll mention also that some people really, really like test-driven development or a variant of the idea, so feel free to use that. And if you want, there are some optional readings from today on the website where you can see different perspectives on test-driven development. Okay, that's it for test-driven, or for testing as a lecture. And so in the future lectures, we're going to talk more about some Java syntax, and that's it for today. See you later.